doing? All right.
I don't know. We're talking.
All right.
We're mainly doing this to check levels.
Okay. Oh, okay.
So
that I can do.
So here's
I can check levels for it.
Let me tell you. Here's what I've learned.
Okay.
This setup is great.
It's awesome. It's so good.
The only problem is the camera is 55 millimeter and it's cropping, so it needs to be a little farther back.
Your autofocus wanders. You should do it like when you're sitting in the sofa.
No,
you're in focus.
It's gonna find it.
Well, yeah, but when you moved, it moved, right?
Yeah. Well, that's because this is an old camera.
Our next guest is Dion. Our next guest is John.
I need a camera. See,
Let's
okay, this is a little tilted.
It really looks nice.
But you know why?
Sony image sensors. No. Great
No.
Elgato capture.
No.
What?
55 millimeter Sony.
Oh, it's the
lens.
It's that super ass kicking lens. Is that one of those? What are they? A series or S series?
It's called GM Grandmaster series.
Grandmaster. So this is a Grandmaster.
Yes, of course it's a Grandmaster.
We're looking at. All right.
What are you, an idiot?
All right.
Okay, what's wrong here? A little bit too far this way.
A little. I'm too centered.
I'm gonna put a piece of tape.
I could have probably have a little more. Let's see.
Yeah, a little more. Yeah.
There we go. I think that's good.
Okay, good. So it's right at that corner.
At the corner of the. Oh yeah. Between the two bezels.
Yeah. Because you don't want to look like you're that friendly.
Yeah, you don't have to.
Because we're already married to other people. What do you think? Is that nice? Now, why is there a little light? Oh, I see.
It's like it's like a virtual background.
No. Yeah.
Aura.
No. Here's the problem. A little light shading. We got visual artifacts.
Oh. Studio lighting for the podcast. Oh my god!
It's gonna be so great.
And for other stuff, I guess.
No, this is my.
Oh yeah, now we got it. Okay. Oh wow, that is really nice.
It's Today Show,
dude. Really nice now.
It's Today Show. What do you think?
What's who are those people? Oh, there's Katie Couric. But Katie Couric is from like 1950.
Yeah, she's probably
the more recent
years
one.
old now.
No, she's 70.
Isn't it scary how women we know are now 75?
They're all.
What does that tell you?
Gulp. It tells you.
That was probably a sexist thing to say. I retract that comment.
Are you actually live? Are you recording?
Yeah, we're recording right now.
Oh Lord. Okay.
We can actually view stats. We can view
posterity.
View stats here.
Okay.
And you can actually see CPU utilization, but most importantly, drop frames. So we're pushing this out at 25 megabytes per second. And we've recorded 640 megabytes worth of data. So basically with this M1, it never skips a frame.
Awesome.
I mean, it's actually pretty amazing.
And this is Max. No, this is Max. Pro is the littler one. Max is the higher one.
Okay.
This is the higher one.
Call Pro a little one.
Trifling.
To say I only have $1
No, but you have. This is the better one. I mean, regardless of those other
those things nailed together. You're right.
All right.
Well, let's see. It's running at 60% CPU. Right, because OBS is primarily a GPU.
Oh, that's cool.
Primarily CPU.
Oh, that's.
And the GPU, but look at the GPU. Running at 88%.
Oh, we're using some GPU. Yeah.
So it's.
I have to get one of those meters. That thing.
Oh, stats.
That's all.
Stats.
Is it stats or iStats? Just stats. Just stats.
Stats.
Okay.
Awesome.
All right.
And then the main reason we're doing this call is we're testing the audio chain.
Oh, okay.
So that thing is never supposed to go above
red.
No. If it goes all red, it's overblown. Hello.
Looks
the limit.
Okay. Well. What?
You can't go above 0, no matter what.
Okay. Well, we're not. We're okay.
Yeah. You know why?
Because you have a limiter. You have
a
compressor. Is that what a compressor does?
It took me so long to figure this out.
Okay.
It's got
how does it work?
A gain system. So you have to set the gain so it's high enough so you're above the noise floor.
Right.
Then it actually has a recurrent neural network that does dog suppression. Then it has a 3-band equalizer because my voice is so thin and nerdly that there's a 6 dB.
Riches it up.
Yeah, makes you
more of a canter,
more of a vibe. Howie Stern kind of thing. And then it has what's called an expander. All these parameters, by the way, like 3:1, minus 20 dB, 1 millisecond attack. This is all, you have to tune this correctly. Okay. So what it does is it takes the sound and makes it louder. And then there's a compressor that says, if it gets really loud, I'm going to compress it down. And then finally there's a limiter that says nothing can ever get above 0 dB.
Okay, so the limiter is really the thing that ultimately keeps it out of the...
Yeah, the limiter is the thing of last resort. 3-to-1 compression at the top sort of makes it impossible.
But you know what might be fun? I wonder if they have a stat on how often the limiter gets triggered.
Oh, yeah. No, you can tell because you see that little bouncing meter?
Yeah.
If that goes all red, stop showing this thing, and it's in at 0 dB.
Oh, the whole thing goes red.
Bright red.
Oh, okay. I remember seeing that. Okay.
And now, let me show you the other trick.
I've seen red before. This device? Oh, yeah, sure. Have one of those. Not with me, but yeah.
So I can actually turn this.
Learned about it here.
To monitor an output and actually hear what's going on.
Oh.
Right?
So you can hear the whole Zoom conversation.
Normally, if I'm doing this for real, I would set the audio to, if I'm just talking to somebody, I would set the audio to, this doesn't work if you're here, but then I hear the audio this way, but I can also hear my own voice. So I can tell it's actually coming out that way.
You get the, what is it called? There's a cool name for that in telephony. It's not loopback, but
it is like loopback.
It's like that, but there's a cool name for it. Anyway,
since our last podcast,
oh boy,
we're officially working together.
We're
finally found a project we can do together.
And it is so fun. It is so good, and people are.
I mean, you look super energized.
No, I really. I
haven't seen you. So happy.
No, it really. I mean, thanks so much for the opportunity. It is super fun. I get 2 things to learn. I get to learn about AI, which is advancing at an astonishing rate.
Yeah.
And then I get to go in and learn about different businesses, like what do people care about in construction? Oh my God, I got the download from one guy yesterday that was so it was funny because it was here's how stuff should be, here's how stuff really is in the construction business, and that's kind of messed up, and then here's how it is in our company, which is another layer of messing up. But the messing up is aside. You just learn like what people care about in these businesses and how it cares. Are the books misaligned?
Lights are not aligned.
Oh, jeez. Okay.
See? See?
So,
doesn't this help?
What if we had one light? What if we just...
No, because they can't have one light.
You want it to be symmetrical?
Yeah.
Balanced.
Yeah, and this part of the L shape, you guys can't see it on screen, has to work so I can watch television while I'm bored. So I got this thing set up. So I don't want to tell you how many times, maybe we'll change the camera. So there's a TV back here, and I can watch TV
while you're on the podcast.
Yeah, because if they're really acting about that thing, morons,
again,
you got to be able to like do other stuff.
So with shotgun, what's the range of that? Like, do you hear it? Like, if you're off that way, I mean, how broad is it?
No. I just leave this on audio.
Okay.
Just leave this on. I'm turning the audio.
But I mean, as you walk around, could you be heard?
No. Okay. Well, we'll see.
We'll see.
Well, actually, you can look at the
little test.
Tell me. Does it still work? Can you hear me?
Yeah.
Okay.
Okay, you're audible over there. Yeah, good. Yeah. I mean, with all that stuff, if you're just whispering over there with the, with the compressor and expander and the limiter and all of that, like, oh my God.
So basically, and then I don't have my full setup because normally I have an iPad here also. So I have 3 devices I can look at.
Well, what do you put on the iPad?
I typically, during a meeting, if I need to look at something, I'll just look at it on the iPad.
Okay. All right. So that's your like reference stuff.
But then you see, I've also solved the tummy cam problem. So you can't put this all the way up because if it's too high, then you see your tummy. Which
I don't like that. I don't like that.
Tummy cam is bad. No. If you actually watch most people, they always shoot like pretty flat, so you don't get tummy cam.
Okay.
But we've got the monitor here, so I could probably go a little lower.
Yeah, but you know, you want also. You want to avoid chin cam too.
Yeah, no, it's got to be. This thing's got to be higher than your chin. It's got to shoot.
The trade-off is chin cam versus hairline cam for me.
Yeah, no, see how this is nicer.
Oh yeah, this is nicer.
Yeah, so now there's no tummy cam.
No tummy cam.
No tummy cam, but it's still you're still down a little bit because that's irritations. It makes your chin look smaller.
It's absolutely svelte there.
Yeah, so this is my, Jang hates it, but this is my studio setup. I'm always moving this thing a little bit because it's not quite right. Because it really bothers me when those two things aren't even. But it looks good, right?
It looks awesome.
And I don't know if you're a camera guy, but the bokeh on the back is beautiful.
Yeah, it's beautiful. It's beautiful.
That's what happens when you have a lens that costs more than a phone.
It's
so that's why people switch to these DSLRs. It's actually not for more resolution. It's just the lenses. Look at the quality of this lens.
Looks beautiful.
Right? And this is recording at full 4K.
Nice.
Think about that.
Nice. Huge. Yeah. On something that's not even a dedicated piece of video recording hardware. It's a general purpose computer.
Everyone out there, Elgato S60 Plus.
That's the nuts. That's
because Elgato, it's freaking awesomely confusing what they get, right? So they all sound the same. Like there's the H60, the S. It's completely crazy. But this is the one. It's got HDMI 4K input.
Okay. All right. What frame rate?
60
4K 60.
I think this is an old Sony A7R3. So I definitely does 30 frames per second out. But it can handle 60.
Elgato.
And it's mainly used for gaming, recording games, video streaming.
Like Twitch streams?
Twitch streams, right? And then you plug the Shure VP87 microphone into the camera, and it puts the audio on the HDMI output. So there's only one wire.
Integrates it. Nice.
Then you need, of course, you need a micro HDMI to HDMI cable.
Oh, yeah.
There's so many different standards.
That's easy to do, right? I mean,
unless you don't have one.
There's the rub. But what about can you get one of those? Those are regular. Best Buy. You get it at
Best Buy, Amazon, whatever it is.
Rite Aid, maybe not, but Best Buy for sure.
And then you need a Thunderbolt cable. This is actually much more complicated because all these USB-C cables look identical, right?
They do. So there's power on. Oh, and we'll talk about USB-C another thing also. But go ahead. Well, so you got to have Thunderbolt, which has the bolt on the side.
That's the only way to know. Right? I just figured this out on freaking Amazon.
Yeah,
because they all say.
But they'll show you the picture.
But the thing says Thunderbolt compatible cable, which means it plugs into USB-C.
So so compatible is like.
But the way to tell is it's obscenely expensive.
Okay.
Because they use some Intel chip. So like this is a 2-meter cable, which is the max you can get.
Yeah.
I think it's 20 gigabits, which is more than enough. And it costs like $40.
Wow.
And USB-C cable costs like $6?
Because it's not really a cable. It's the cable. It's like a transmission system, right?
Well,
There's all the like level changers. And there's a lot of. There's basically a modem on each end of that.
Exactly. There's 2 chips inside, and this thing is actually 4-lane PCI Express. That's what Thunderbolt really is.
Oh, interesting. Oh, I did not know that.
So each lane is 10 gigabits.
All right.
And so that's the whole trick.
Okay, cool.
Okay, and then you have to plug it into a Thunderbolt compatible laptop, which is a lot easier with Apple, right? Because they're all compatible.
That's not tough.
That's easy, but that's how you get. Isn't that great?
Cool.
It works.
And here we are, and we can chat. We can chat. And we're all compressed, so we can be quiet or we can be loud, and it all goes like green, yellow.
Try this. Talk really quietly. See how much it's pushing.
Just still gets.
So what you do is there's a great YouTube video that I will link to in the show notes. How you set this. All the guides on the internet are wrong. They're completely blown, except for the video guy on YouTube. Show notes. Check it out.
Get your show.
And it takes like 30 minutes to figure out how to do it.
But if you have the show notes, you can just like yoink, 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 yoink. Or how specific to the setup are those parameters?
Totally specific.
Oh, you must be.
You have to understand what that little liney thing means.
Mm-hmm. Okay.
And basically, the liney thing means it should essentially always be in the red or the yellow.
Okay.
It should never be in the green. The thing's completely stupid the way this thing works.
Okay.
It should be the other way around.
Misleading. Yeah.
It's totally misleading because the green means it's too low.
Okay.
That should be black.
But green means good. Like everybody's intuition is green.
Right.
Good.
Right. But it should.
No.
That thing that's yellow. That thing that's yellow.
Yeah.
That's good. That's like okay.
Yellow is like the best.
And the thing that's red should be green. Because that means you're getting good.
Oh no, you want to be in that little red.
Well, think about it,
section.
right?
Okay.
In the old days, red was bad because it was analog. But in the new days, this is like I don't know how many bits of audio.
Mm-hmm.
You want it all to be up to the right.
Yeah.
Because you're not going to overload anything. You want to use, and you want the noise floor to be as low as possible.
Yeah. Okay.
Right? So there's this thing in cameras called. Have you heard of ETTR?
No.
Exposed to the right. So real camera people, they don't take pictures that are perfectly exposed. They expose it all the way to the right, as much brightness as possible, and then they fix it in post because otherwise all the low signals get lost.
Get in noise.
So a real pro, if you look at the thing on the camera, looks horrible. You're trying to get above the noise floor,
and then you just crank it all down.
You don't want to get crushed on either side. So the trick is that all these, like even this OBS studio thing, is designed for the old analog days, but actually everything should be in that part that's red. It should all be cranked to the right because you're not losing anything down to the other side.
All right, cool. I've never heard of ETTR.
It's the nerd.
I love that. That is so good. Yeah. That is so.
But when you look at the problem, of course, is it looks horrible right out of the camera.
Yeah.
So it requires processing.
Yeah.
So that's what there's that histogram thing no one ever looks at.
Yeah. Yeah. Never. I
rarely
look at it.
You look at it. So you want it. You never want anything down to be towards the right. You want it all the way. But you want it crushed against the right.
Right.
You just want to push to the right as much as possible.
Because then it all gets limited, and everything that's pretty white looks utterly white. You don't get any detail in that.
If you lose all detail, then it's way against that side.
Yeah.
So you just want to turn your exposures.
The one of those that I love, the histogram of those that I love is the R, G, and B ones that are separate.
Yeah. Those are so cool.
I think RX100 has that.
Yeah.
Oh,
it's so cool.
I think it's so good. Yeah, I love that.
Yeah,
and I learned today to use that to get more exposed to the right.
But the crazy thing is, of course, these are all just computers. Why don't they just have an ETTR setting? I mean, you could easily measure the image, right? Determine what's crushed down there.
All right.
And just push it to the right such that, the thing's all... I don't understand.
Okay, here's my idea on why. Because the human, the operator, the photographer, knows what the course of brightness will be for an entire scene.
But this is what you're doing now in our little company, right? That should just be, hey, Sony camera, I want to expose ETTR now.
And a polar bear is going to cross in front of the camera 30 seconds in.
Exactly. I mean, that's what we're having so much success with. I mean, there's so many things.
The polar bear.
Yeah, the polar bear. The polar bear is exactly right? I mean, it's crazy that we don't have these. You think about natural language interface, it seems like a toy, but actually, the thing you just described would change like 55 settings, 7 layers deep in the menu, and you just want to change it. And
nobody could ever do it manually. You would never remember all of them.
Well, for instance, this camera to get it to work in this mode, and I'll put this in show. 7 settings, menu 42 left, go down menu 40. It's just nuts.
It's
right. As an example, the default for this camera, it shows all of the little video gewgaws, like the histogram would appear. So you have to change the HDMI setting to remove display, which is literally like menu 6,
right.
Go down 6 items,
3 levels,
3 down, and then you pick some obscure thing like a display off. It sounds stupid.
Right. You want the display on. I mean, you're looking for a display. But no, it's the histogram display.
Right. And then this thing has a custom settings menu.
Okay.
Where you can remember those settings.
Good.
Right?
Good.
But it's not called custom settings. It's called something else, which I can't remember anymore. Custom is that word is reserved for changing little buttons on your camera.
Oh, okay.
So if you search for Sony custom saving, you don't get what you want.
Okay, you get like
it's called memory
button. Oh, okay,
it's called memory instead of custom.
There are a lot of things to remember in this world. So calling it memory does not.
But that's the great thing about large language models. You know,
does the camera have? Does the body have an API? Like, could you drive that thing?
Oh, yeah, no, you can drive.
We could write we could write a little thing like tell an LLM what the body API is,
build it in the
and then
build it in. I mean,
but I'm not in the camera business, Rich. But if the thing's got an API, I can drive it from a.
But the point is,
LLM
all of this stuff. I just think the arrival of generative AI is about 3 amazing revolutions in one. First of all, it flattens all the user interfaces, right? Like even that crazy filter thing I just said, that's way too much complexity.
Yeah. Oh, you could totally do that.
You just say, please make this work, right? And then the other thing is actually understand some things you're talking about. And of course, the third thing you're working on is you can actually inject all the information. Like you could know, for instance, this whole thing should work as a unit.
Oh, man. As a unit, that has sold me. I love that. Oh my God! I mean, why? So you could have a system that had like all the cameras and all the production studios and all the whatever the encoders, the Elgato guys, and then like you say like for my setup, and then it just knows.
And it should just generate whatever that weirdo JSON. However you set these things, just work.
Big jungle of setup.
I mean, we're all so it's going to have a huge impact on the enterprise, but the consumer electronics implications. You might actually want to remember how to use this stuff.
Yep. Like security cameras. Oh my God! Like, I mean, setting up a security camera.
It's like
you're like, how often do I want it? Like, like I don't need motion detection on the one that's by the patio. Like, or the most frequently used one, increase the frame rate. Or there's.
I just spent 2 days because Apple Home. We have, I think, 12 cameras here now. We've got outside and all this other stuff. To get the notifications right, you have to go to every camera menu, every camera in Apple Home. You have to change 8 settings.
One by one.
One by one. Over and over and over and over, right? Now, you and I could automate it with, we'd have to go figure out some
make a shortcut.
home automation shortcut thing. It'll break immediately. Right? Because it's actually software. That's what needs to go away. Totally go away.
Yep.
Right. I mean, this is this whole
just ask for what you want.
Generate the right stuff, right? And then someday maybe it'll even anticipate what we want.
Maybe.
That's the kind of
that's in the future.
Yeah.
But the stuff about like learn this menu or learn this API or like and then just describe what you want, like your desired state to the thing is really possible, and it's amazing. It's astonishing. I mean, the stuff we're making, like the sophistication, the automation, and I mean sophistication, automation behind, but the simplicity that it brings in the front end is incredible. When we show this to people, oh my God. Oh,
what is that? That one
so fun.
Your friend, the architect guy.
I said, like, I need some.
You should shift it with duct tape.
I need some gaffing tape, or not gaffing. Gaffing's TV production, but yeah, I need duct tape.
You should, every time we do a demo, you should ship it with tape so people can wrap their jaws closed.
Yep. It was that was so fun.
But
that was so
every meeting's like
we do that over and over and over. Yep.
And here's the funny thing, right? I mean, it's all open source.
Yep.
It's not like remember the Microsoft development kits $7,000. You can only get it if you go to the developers conference and all that stuff. Now it's like but the only limit we have is time, right? Like I wake up in the morning and like I need to learn so many things. Like how many things? I mean, every day I just feel like I'm falling behind.
Yeah.
Because I read something and it's like, oh, this could change my life.
It reminds me what we were talking about before. About first we have the happy birthday Paul and Ton podcast. So it is Rich's birthday today.
And also
Friends, sure.
Vive France.
Okay, France
Vive
and Rich. So you wake up and there's so much stuff to learn, so much open source stuff to learn. So your big gift today to yourself will be taking the time to learn this thing that you are curious about out of this avalanche of stuff that's flying.
Okay, so here are the things that I really want for my birthday. First thing is I send notes to everybody, including you. This podcasting thing is actually pretty important because it's like this record.
Yep.
Yeah, I feel like here's Galileo, here's Newton, and we're discovering this stuff, right? It's like, oh my God, oh Jesus Christ, I didn't know this. I'm just fascinated by the history of engineering and science when you hit these inflection points.
Right. In 100 years, what is this going to look like?
Oh my God, we were at the beginning of this crazy revolution.
Yeah.
But the second thing is, you're totally right. Like, as an example, did you know that Claude V2, competitor to OpenAI, just shipped 100,000 input tokens?
Wow. What a window. What a window.
The thing is totally free.
Wow. I should set that up today.
See, this is my problem.
I should get it going.
No, seriously, get it going.
There are 20 things every day that you want to set up. Like, I should try that. I should do it to see what that goes. Okay, so all right. Okay, sorry, you're on an arc there. You have number one. You have number two.
Those are my two big things. All right. It's literally like you wake up in the morning. Usually when you're doing programming, it's like every 6 months or a year. There's sort of an interesting package. Right. You should check it out.
But you're mostly reading like Kernighan and Ritchie.
Kernighan and Ritchie is still like the standard text for everything, right? Absent syntax. Nothing's really changed that much.
Yeah.
Have you seen this thing? I just heard about this yesterday. LeetCode.com.
No, I don't know about LeetCode.
Okay, so here's the way that the bar to like get into a Google work. They give you these like basically Wordle coding programs. Like you never do these. Like
not practical, not real world. Well, they're just like goofy puzzles.
No, let's put it this way. No, it'd be like, I want to be hired as a dentist. Please tell me how to make a toothbrush.
Okay. Like, all right.
Would you like?
So it is more specifically the lower level stuff that you would really just assume if you were doing this job that you're applying for at Google. It would be like probably in a library.
No programmer in 2023. This is the first question. Is a test question. Write a login search function for an ordered list.
Yeah.
It's like, okay, I could probably figure this out, and I'm really glad there's like a million people on this thing memorizing this. But it is like, here's how you put bristles in a toothbrush to become a dentist.
Yeah.
It's like no one on planet Earth.
It's just it's not practical. It's not the real problems you're going to solve with this job.
It's like no one, there's probably only 2 people in the world who've written that sort. It's in NumPy or something. And your mission is to go find it and use the right library.
Right. Or ask ChatGPT.
Ask you the right library.
I mean, if you're working at Google, you're still going to ask Bard, but fine.
And of course, the language, it's using C++, which is like so over-engineered for this challenge. Like make a class. I mean, who cares, right?
Yeah.
Who cares?
Literally. List and what you're searching for and go.
Well, it's a Python intrinsic.
Really?
Yeah. I in bracket 1, 2, 3, 4 returns it. But it's not even a function. It's not even a library. It's just an intrinsic.
Right there. Just.
I mean, what you really need to know is for I in bracket list, is that efficient? That's actually an interesting question. But believe me, that Python thing is just calling C, right? I mean, that's the funny thing about it. Python is like this minimal wrapper around a bunch of C functions.
C functions, yeah.
Right? And so it doesn't even matter And of course, the crazy thing is, guess the size of the list they have to test. 5 items.
Uh-huh. So
like, who cares about log n?
Yeah, n and log n are
crap.
pretty close.
Pretty close.
It's goofy.
So anyway, so I think the problem is that, in programming, we're so focused on like, do you know how to make a brass screw work?
Mm-hmm.
And we're trying to build like the Empire State Building.
Yeah. Uh-huh.
Right. So we're testing people on, and by the way, you and I would fail this leak code thing.
I'm sure.
Instantly.
I mean, yeah.
Right.
I probably never would have passed it,
but you don't need to pass it.
I don't need to pass it.
Right. Yeah. And like most of it is like memorize Knuth.
Mm-hmm.
Right? But who needs to? It's sort of like, do I really know how to make Egyptian Sanskrit? I mean, I just don't need to know these things.
Okay. How about this though? Okay, I agree. Write your low level, write your n log n sort, fine, or your log n sort. But what about knowing those, not the implementations, but knowing well the menu of them so that you can know how to solve the higher level problem.
But here's the hilarious part.
Okay. Guess
how it works. So you're given this test by Google.
Mm-hmm.
You take it home.
Mm-hmm.
What? It's like this IQ test. You can either learn frickin' leakcode.com,
mm-hmm.
or you can just type into ChatGPT, make me an insertion sort, and paste it in.
Okay.
I mean, come on, guys. Why are we're wasting everyone's freaking time?
Yeah, it's
like an IQ test. If you can't pass that test,
mm-hmm.
there's something seriously. I mean, maybe that's the whole point.
Mm-hmm. Mm-hmm. But that seems like a rather low bar. A take-home test really seems like a low bar.
But it's so low. It's simple. It's like,
yeah, no, I know it's
ridiculous. And apparently this leakcode.com thing is like a huge business. People are studying this stuff.
It's a like a subscription thing.
Of course,
you pay for it.
Of course.
Yeah. So,
and by the way, people crowdsource the questions that come from these big tech companies.
Oh, okay.
So it's like an entire corpus.
Right. I just went to Google and they asked me this. I went to Microsoft. They asked me this. So, all right. So, but you touched on a thing a couple of minutes ago that I want to return to, that I've been curious about, that I bet you know the answer to. So, as these models get a larger and larger token inputs, like you said, Claude 200K, right? Claude 200K. So, do you really, can it really, in that 100K, if you're shoving it in, ignore things? Like, does it know what's relevant and irrelevant in that 100K? Like, would you just shove it a whole book, or do you get better results if you thin what you put in as the input?
I want to try this afternoon, man.
Well, I think we should. I think we should try. But I mean, it seems like, yeah. Well, okay. Here, this gets back to the sort of philosophical thing that we have talked about before, that you brought up. Like, you have CNNs, RNNs, and then transformers build the previous technologies into them. It goes built into their networks. I wonder if, in a like way, like a really awesome Claude 2 transformer model does a very, very clever pre-filtering, such as one would do, like we're talking about, getting relevant stuff out of a big corpus of data using a vector database, like a semantic search, and then just the right stuff goes in. So I wonder if something that somehow gets built into Claude.
Well, I mean, that's clearly what's happening. People have hand-built models that basically give selective attention.
Okay.
There's a bunch of research about that. Right?
Okay.
So given the n tokens,
mm-hmm.
how do you figure out which tokens are important? Right? It's called sparse attention.
Oh, okay. All right. Okay.
But I think what's happening is that sparse attention, instead of someone doing it by hand, is actually just in the model itself.
Okay.
Right. So presumably when you use a word like JSON, for instance,
mm-hmm.
in the 75,000 words, 100,000 tokens,
mm-hmm.
it goes, oh, I'm going to light up things that look like JSON.
Okay.
And so that that's the whole point of the tension is.
But you could still distract it, right? You put in JSON 500 times. You put in HTML, 600 times. You put in Ruby 400 times. Like, whoa, I can't. Well, remember, it's confusing.
Remember, these things are completion systems, right? So the text corpus, for instance, might be the whole, like the Bible, right? Just doing text predictions. So you're just increasing the length of the input stream before you have to read out the output.
Okay.
Right? Okay. So presumably you could load in the entire Python manual, the entire NumPy manual, and then if the output you want to generate is the code examples, it's going to get better. That's the whole point. Right? So feeding in an arbitrary 100,000 tokens, hopefully all of that sparse attention that's built in there focuses on the right things.
Yeah.
That's the whole idea.
All right. I should go upstairs and learn about how sparse attention works.
So, you should learn how sparse attention works.
I should.
I don't know how sparse attention works. Well, I made all that up, right? But
that is one of the many things that we share is like a willingness to like make stuff up from things that like by first principles have to be true, and then you just kind of assemble that into a model that is at least internally consistent, right?
So, yeah, I think you have this conceptual model of how it works, and the thing that's we had this thing called what's all this then about ChatGPT, and everything we've been doing here has a conceptual model. Imagine if you didn't have this conceptual model, right? Like the conceptual model I have is, as we talked about, the large language model is huge, but built into it are convolutional neural networks that recognize text or recognize images, recurrent neural network models that recognize text flow. And that's the way we've been thinking, right? And the attention thing is all about certain symbols that you get sort of turn on different parts of the model, right? And so that's how you and I are thinking about this problem. So when you have 100,000 words, what's really happening is you're kind of priming it.
Okay.
Right. So those words, for instance, if those words are all about JSON, blah, 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 Python, presumably the parts of the network that understand semantics of programming are turned up high. So on the output, you basically ignore all the things that understand Shakespeare, right, and all that other crap, and
that's all dark. Like you stop paying attention to the
and you just kind of turn on this network. And amazingly, people are like, "Oh my God, did you know what? If I take a specific network and I hand tune it, it's better than a transformer." Like we just got this on the WhatsApp, right? It's like amazing. It shows that transformers are not needed. My reaction is, yeah, but you have to know to use that model for that purpose.
Right.
That's the point. The whole point of a transformer is I don't have to think about what the input is.
Yep.
And handcraft this thing. So someone just showed amazingly, like the thing that recognizes zip codes. Right? This model, it's like 80,000, 80 million parameters, something like that. And amazingly, that thing outperforms a transformer doing zip codes. But it sort of misses the point.
Yeah.
The point is, I didn't know I was doing zip codes.
Just,
it's sort of like, I've got a car that's really good on rutted roads, or I've got a car that can do everything.
Yeah.
And then you're like, well, if I'm on a rutted road, I should use the little car. But the point is, I don't know I'm going on the rutted road.
Yeah. I'm just driving a vehicle to get places. You don't know what your road is going to be.
So sometimes I don't know how to react to things on these groups, right? Because we're up to almost 50 people, and you feel like saying, you're missing the point here. The point is not that you and I can't craft a specific model for a specific purpose. That's not the point.
Right.
Just like, by the way, all these things would be better done in assembly language and much faster. Much, much faster. But that's sort of not the point.
Yeah.
Who cares?
Right. It's like a processor versus an FPGA.
Yeah,
right.
Exactly.
Like you want, at different scales and at different.
But it's very analogous, right?
Yeah.
I mean, the Sony camera has got a bunch of FPGAs programmed just to do image processing, yada, yada, yada. But the problem is, if you now want to recognize 6 faces instead of 2, you're screwed. Because that FPGA was designed to do 2.
Yep.
So this is the general purpose versus specialized thing. So every time anyone says to me, "Oh my God, the specialized thing is so much better. We can throw away all the general purpose stuff," I'm like, "That's great." As long as all you want to do is
specialized. Until you have to do anything else, and then I wish I had that. The other thing that's like 6 times as big but does everything. Right. So anyway, crazy.
You have to go.
I'm well. We should wrap.
Oh, let's see. We should wrap 39 minutes. Perfect. We had 23 minutes of commercials. We can have it. We can have a TV show.
Joe Rogan, look out! Look out!
Let's see.
Or Leo Laporte, look out!
So here's the other thing I've learned. Remember that thing we started where we had to have like a script and our talking points?
Right.
If you're in the middle of a revolution, you don't need any of that.
Okay.
Everything's interesting.
Everything is fresh and
like it's all actually completely interesting. 2 weeks from now, I'm doing a hackathon thing, right? And literally, it's like, what is the prep? Because if I prep something now,
it'll be out of
date. I don't need to worry. It's just like the night before. It's like, what's just happened?
Yeah. It's When for a few weeks, I was waking up and I would like look at Twitter for 15 minutes and find 5 things that were new, that were important, and were like literally specifically relevant to the work I was doing.
Can you believe
it? It's unbelievable. And that's what makes it fun. Coming back to the beginning, so fun, so interesting, so energizing. It's like it is so dynamic.
I'm going to put in the show. I'm working on this thing, which is amazingly, there is no simple Google Colab notebook just to get up to speed. If you think about it, like it's actually all kind of complicated. So I'm just working on this simple project. Like you don't know anything, but you're a programmer. Here's the minimum you need to know to get this thing running. So I'm working on that.
Wow, but what do you start with? What do you assume?
Oh, I would start.
Those are weird. Like
I would just start with OpenAI.
What are the levels? Okay,
right. Put in one prompt. You know, just that's the great thing about collab, right? I mean, it's this idea of what is it called? It's not narrative programming. I think where you write text and then you run things. It's got a term. I always forget it. Literate programming.
There it is. Good one.
Literate programming. It's super useful, but no one keeps these notebooks up to date. I'm using them all the time. So I'm just going to have something that's up to date on the website that I'm going to maintain just because once a day I talk to someone who wants to learn how to use this stuff. and you know this. You don't have to be much of a programmer.
Yeah, right. Because
it's not like you don't have to learn
I'm not that much of a programmer, but I do this stuff.
Yeah, and then Python, you can actually read Python.
Yep.
I mean, it's code. You can understand what it's doing. It's
very intuitive. Very easy.
And no braces and brackets.
Yep.
I mean, actually, for humans, the whole space thing is actually very understandable.
It is a great way to convey
people understand indent.
Until the ML stuff. I used to be like Python. Oh, that's like goofy, and that like the. And I actually resented the indentation thing in Python at a vast distance because I had very little familiarity with Python. But now it seems like, oh yeah, that makes sense. And it gripes about it, and then you fix it, and you're fine.
Well, part of it is that we're used to code that has like 17,000 curly braces.
Right.
You look at like React code. That stuff is crazy. It's like close. I think there's something wrong.
Right.
If you're that far down. Yeah. Bracket curly square. There's something wrong with the language.
Yeah.
If you're that deep.
Yeah.
Right. How many times do you sit there going bracket, curly square, and then it's so sensitive to this stupid comma. You miss a comma, it's what the hell's going on?
Yeah.
It's nuts.
Okay. So we should we do another episode and we can think about like what does that lack of punctuation in Python cost you? Like does indentation really fully replace it?
So my personal view is that all that indentation stuff is because our compilers are relatively stupid. Like humans don't. It's not like when I talk to you, I'm like, hold that thought, think about this thought, hold that thought, think about this thought, hold that thought, think about that. I mean, it doesn't work that way, right? But because most of these compilers and things are so close to the metal, right, that you shouldn't have to do all that stuff.
Yeah,
right. That should be like machine level assembler code. Pushing stack, that's not the way we work as humans.
Yep.
And you look at what you want to make. You want to make like a widget here and a widget here and a widget here. And they make you write all this code. You just get 3 widgets. That's how come I'm so excited about this. Make a website with NLP.
Oh,
because that should just like be some intermediate compiler stage, right? React template should be like the same way you think about P code or anything. It's just the jump down on the bottom that makes things efficient. But no human should ever write.
You don't really know. You don't really know. Just like you don't know about your login sort. Yeah. So, all right. So let's make some coffee before we have our coffee. We have our next show. In 12 minutes.
12 minutes. Okay. Right. Bye.
Paul and Ton back on.
See ya. This is fun.